Let us look into a problem which is called Java sort. This is from HackerRank data structures section. And this problem is about, we have given a list of students with three properties: ID, first name, CGPA. And the problem is uh, about we have to sort the list of students according to their CGPA in decreasing order, starting from the highest to the lowest. If two students have the same CGPA, then we have to arrange them alphabetically in order of their first name. And if two students also have the same first name, then we have to order them according to their IDs. And no two students can have the same student ID. So here, there are various approaches. I'll discuss three approaches to solve this problem in Java 8 and later. And there is also Java doc you can refer about object ordering. It talks about collection.sort method, which we'll look into this video. And it also talks about comparators, and this also will be studied. And in addition, we will also look into our latest approach, which is as per the latest language changes. So not provided here. So let's start solving this problem. So here we what we have to do is simple to sort this list. We have the list already scanned from the system.in, which is the standard input keyboard. So here, first thing is, we read the input, which is the number of students, and then we get details of the students. The ID of the student is the first number, followed by the first name, and then the CGPA. So let me arrange this. Yeah, so we see the solution side by side. So this is the custom or the template code which have been provided. So they have defined the student class for us, and now we have to write the sorting method. Also, there is code already provided to scan the list of students and put them into an array list, which is a student list. So to sort them, it's very simple. You use collections, which is a part of java.util package, and then you say sort, and then you provide that list. So in this case, student list. So, but yes, the student list is not a standard primitive type. So we have to provide our own comparator. So here, the way we sort is we provide our comparator. So let's put the comparator here itself. Assume this is something ad hoc sorting we have to do, and we don't worry about too much of reuse and maintainability of the code. So we can just write here comparator dot comparing, and then we say first thing we have to compare is get CGPA. So this is the function reference, and here is student, and get CGPA is the method name of student class which can be used to sort these elements. But we have to sort in the decreasing order, not in the ascending order. By default, this will sort in the ascending order, so we have to say reversed. Now, this is the first comparison, but then we have to provide other comparison as well. So let me put in the second line, and so let me make this more organized. Just put this in the next line, and now here we can have more methods here. So dot is reversed. So first thing is, okay, let me put it. So comparing. So first is dot reversed. Yeah. So let me put this first sorting here, and then next thing is we have to say sort by uh, dot. No, then comparing we use like this, and then say student. And next thing is we have to sort by the first name. So say get that name. 100, which will get the F name. So yeah, this makes it more clear. So here we sort them by uh, first name, and then this is again in the alphabetical order, ascending order. So need not have to use reversed, and then comparing, and then last thing is student. Then we say get ID. So if we do this, this is a very readable functional way of writing the comparator, and here we can use it and see if this result is as per our requirement. So let's run this, compile this code to check for any errors in case we have. Okay, so I'm compiling this code. Okay, I see then comparing. So, okay, so yeah, you have this comparator, and comparator is the second argument. So yeah, here we have to put a closing bracket. Then, so first argument student list, second argument is comparator, which is comparator comparing CGPA, then reversed, then comparing first name, then comparing get ID. So let me compile it again. So yeah, this is as expected. If I run this against all the test cases, let's see if it passes all the test cases. Yeah, so it passes all the test cases, and this one of the solution. Okay, so let's now for the time being remove this. Let's which one, and there are other approach. So assume no, we don't want to write this custom sorting logic in a client. We can put this directly to a student class. So the way we can do it is in student class, let's say we want to make it by default support comparison. So we can say comparable. The student class implements comparable interface. So what does it make? What does it mean is, sorry, so here implements comparable interface, and this comparable interface is a generic interface. So we provide student as the name of the class, and now we can override a default method. It's a functional interface again. So here we can say there's a public method. It returns integer, and then that method is compared to. So this is by default our logic to compare students. So here the comparison logic is inbuilt into the class. So we do not have to write in our main class or in the clients this logic. So here the way I implement it is, so here, we have student st, and now we have to say that CGPA, and if this is not equal, then we have to say this get CGPA. So this one will, so if it's equal, then we have to compare first name. But if it's not equal, then we just return what is the result of comparison. So which is result of comparing the argument, CGP of the argument object, and then the original object. So this will compare the CGPS and return the CGPA here, and use ST first, so as to get the decreasing reverse order of CGP. But for others, I'll use so here return. So next, if it's equal, if the CGPAs are equal, then what I do is I have to compare the first names, and if the first names are also equal, it's the get first name, and this happens to be equal to the first name, which is for consistency better readability. It's preferable to write. This doesn't make much sense, but that equals So this dot get name is equal to the what is passed in the argument. So then we have to compare the IDs. So in this particular case, if it's equal, then we say compare ID, and compare ID is just get ID and return the IDs in ascending order. But if strings are not equal, then what we do is we return this dot get that name and dot compare to string dot get. So now to check this, what we need to do is we just have to just write. So let me put comments which is approach to, which is using comparative interface. So here, since I have a comparative interface, so I just pass student list, and the list will get sorted and it will get printed in the subsequent. So that's all about the code. Okay. So yeah, small optimization I can do. Scanner, which is for reading the input and then all the reading in the while loop. So after this, I can just let me see if this second approach is compiling and working successfully. So I see, yeah, this compiles and is working. This is for the sample test case. Let's run it for all the test cases in the system. So it's running for all the test cases, taking time because there are around 7 test cases. And yes, I see this is passed for all the 7 test cases. So this is also as good as the previous one. This is, but yeah, it's part of the comparative student interfaces. Now let's assume there is another scenario where you don't want to uh, implement this comparable inside the class, which is your data model. You want to separate this out into a separate class, which is you say student comparator, and then here you get flexibility to implement various kinds of comparators. So I write a new comparator. Comparators will have a compare method. It's called comparator, which is again a part of java.util package. And then in this, we override a method which is public int compare, and it takes, say, student A and student B. So this is exactly same as compared to only differences it takes both the objects which has to be compared, and the previous one, since it's part of the same object, you can use this as the first object, the original object in which the method is called, and the other one is the second object which is passed as an argument. But in this compare method, you have to pass two objects. So since it's an external class, so this provides you advantage that you may have different kinds of comparators, and you can create maybe here I can name it as uh, this comparator is my CGPA comparator, peak comparator. So here student CGPA comparator, or we can just name it as CGPA comparator. Now you may have different kind of comparators like first name comparators or ID comparator, and then use them in your client object. This provides you extra flexibility and maintainability, and you are not required in this particular code can be removed, so you don't need this in the student class, and your class just contains your business logic and comparison logic is in a separate class. So here, what we will put is exactly again similar logic here. So exactly instead of this, we will use A and B as two of the objects. So our first logic is if A dot get C G P A. So this is your object which you get. If it's equal to B dot get GPA, if they are equal, then you have to compare the first names. F name dot compare to first. Yeah, you compare A dot first name and then B dot first name. But yeah, if the first names are also same, then what you have to do is you will do this comparison if they are not same. So you just return this, and but if they are same, then you say get ID. You return a dot get ID. So this is a way you can compare them. It's exactly same as writing integer dot compare. I can do a dot get ID, b dot get ID, but this gives you the same result. If a is greater, then you get positive result. Is negative, a is so okay. Only thing is this is yeah, this is integer, so you can use it here. Now if this is equal, then you compare first name, and then if it's not equal, now we have to put the else logic here, which is we return double dot compare a dot get b dot get gp. Here this we have to compare in the reverse order difference. So yeah, this one is the code for comparator. Now let's use this comparator. So to use this comparator, we have to take some extra care. So here we can't now directly use this. So approach 3, we have to use using here. What you do is you create comparator, which we call C new CGPA comparator. So once you have the new comparator, we can just pass this comparator to our collections dot sort method. So first argument is the list, and then second argument here. So this one should work. Let's try this. It's compiling the code. I see. Okay, there are slight typos, missing parentheses, probably. Yeah. So just some typo. So get CGPA first name is, and then this method is capital. I think yeah, that's the only change we have to do. Any other error? So b dot f name, b of that student, parent cannot find single f name. So in this we have b, a is the student, get cgpa, b dot get cgpa, a dot okay, yeah. So we have get here, get, or just bored of typing the same thing again and again. So that's the reason for getting these errors. Now, one last, I think, is missing return statement, which is at line 35. So here, yeah, this one we have to say return. And this now hopefully should compile. Fixed, and then it's also passing the test case. So let's run this for the broader set of test cases. So there are 7 test cases. Let's see if it passes for all the 7 test cases. Yes, successful for all the 7 test cases, and we have cracked this problem. So I hope you enjoyed it and you have learned 3 different approaches for comparing the objects and using some custom comparison logic. And in case you like this video, do share your like and comments encouraging me to create more such videos. And in case you have any queries, also feel free to write below in the comment section your queries or suggestions, feedback. Thank you.